Hi, good morning, students. So in the last class, we discussed about rain and umbrella and riverboat problems and relative motion problems. And so now in today's class, let us see the remaining concepts in that relative motion. And so in that, one of the important concept is finding the minimum distance between two objects in motion here. When two objects are moving, then we can find the minimum distance between them. So one method is we can use the differentiation by using the differentiation method. That means by using calculus, we can calculate that minimum distance between the two objects, and we can also solve that minimum distance problems with the help of this relativity. That means when you are applying this relativity, what will happen is one object is considered to be at rest, and other object is only moving with respect to that object. So that means that two body problem will convert into the one body problem, and so that means only one object will be at rest and other object will be only moving, so that we can solve such a problems easily. So for better understanding of this concept, let us see an example similar to that of our previous class. So let us see one example related to this relative velocity here. So in this, let us consider when two objects are moving like this. That means like a sheep and a line. Let us consider here when they are traveling in same direction and when they are traveling in opposite direction. We know already how to find this relative velocity here. We in one-dimensional motion we discussed already. Like just to be velocity of sheep with respect to the line, you can write, and so that they are in the same direction means then Vs minus Vl, or when they are in opposite direction means Vl minus of minus Vs, so that Vl plus Vl you will get. That means in one-dimensional motion, we already discussed these examples when they are traveling in this same line, right? Now let us see the two-dimensional problem here. That means they are traveling in the different directions. That means the ship is traveling along this line with a velocity of 4 meters per second, and this line is traveling along this line with a velocity of 3 meters per second. And so now both are traveling along this perpendicular direction. That means now they are not along the same line here. So now let us see how it will appear when you are observing with respect to this line. That means let us see how this ship appears to be moving with respect to this line here. So with respect to this line will feels that that line is at rest, and everything except this line will be traveling in backward direction with a velocity of 3 meters per second, as we discussed in the rain and umbrella example there. So that means only that line feels that line is at rest, and remaining everything is traveling in backward direction with a velocity of 3 meters per second, including this ship also. That means everything except that line, everything will travels back in backward direction with a velocity of 3 meters per second. So right. So now let us consider with respect to this line here. So with respect to line, now we can observe like this. So with respect to line, now according to this line, as I said, everything is now moving in backward direction. The line feels that it is at rest, and everything is moving in backward direction with a velocity of 3 meters per second. Right. So that is the feeling of this line. That is same as that of when you are sitting in a bus or train, everything outside the bus or train appears to be traveling in backward direction. So, right. So in addition to that, this ship is also traveling in this direction towards right with a velocity of 4 meters per second. And so that as seen by the line, let us see this. Ship travels a distance of, in 1 second time, if I consider, it travels a distance of 4 meters towards right. So it is traveling 4 meters towards right. So this distance is 4 meters per second. It is traveling a distance of 4 meters. That means initially it is here, now it is reaching to this position here. So that is 4 meters per second. And then in addition to that, everything according to the line, everything is moving in backward direction here. So we have to pull it in downward. That means now it is traveling like this. Along this direction, it travels a distance of 3 meters per second. Because line is traveling with 3 meters per second, so that the line feels that everything on this in the surrounding will travel with a velocity of 3 meters per second in backward direction here. So that means with respect to this line, the ship appears to be moving like this. That means initially it is here, now it appears here after 1 second. So that means the line will travel a distance of we can say this distance here, or we can write it as by using Pythagoras theorem. We can write this expression here. So that means now the direction of velocity of the ship as seen by the line will be along this direction here. So initially it is like this, now it appears to be traveling along this line as seen by the ship, right? So that means that is the feeling of this line. The ship appears to be traveling along this line here. It is not traveling along this line with respect to the ship, with respect to the line. So it appears to be traveling along this direction here. So actually they are traveling like this. It is with respect to ground, it is traveling. So for the line it appears, see this, it appears like this. For the line it appears to be traveling, the ship is appears to be traveling like this. At different instance of time it appears like this, right? So it is a feeling of this line. So that means in this case the line appears to be at rest. That means the line feels that it is at rest. The ship only travels along this direction here. So the ship only travels along this direction here, and the line feels that the line is at rest. So that means now we are going to apply this concept for the remaining problems also. One object is at rest, the other object is traveling along this direction here. And so now its value we can calculate by using this Pythagoras theorem here. So hypotenuse square is equal to side square plus side square. So we can write this expression as under root of 4 square plus 3 square, that is hypotenuse square is equal to 4 square plus 3 square, so which is 25, and therefore this hypotenuse we can write it as under root of 25, or which is 5, and it is for 1 second we are traveling, 1 second we are taking here, so 5 meters per second we can write here. So that is the distance traveled by the ship with respect to this line. So right there, got it. So that means now we can calculate this two-dimensional problems easily if you are applying this concept here, that minimum velocity concepts or any other relative motion concepts we can solve easily if you are considering this concept here. That means the line, one object is appeared to be at rest, then other object is moving along this direction here. You can, this is the magnitude of the resultant velocity, and you can find this direction of this velocity also just by using this trigonometry. Like suppose it is theta, then right angle triangle it is. So from that right angle triangle you can write this as tan theta is equal to opposite side by adjacent side. Opposite is 3 by adjacent side is 4. So 3 by 4. Therefore theta is equal to tan inverse of 3 by 4 we can write. Tan inverse of 3 by 4. So that is the direction in which that ship appears to be moving with respect to this line. So that means that when line is when you are calculating with respect to the line feels that it is at rest, then the ship is traveling with that velocity in the direction there, right? And this actually this concept we can also apply by using our relativity concepts there. That means velocity of rain and velocity of line, you know that. And now this relative velocity concepts we can apply here. By applying that relative velocity concept also you can write this case here. So VSL, that means velocity of ship with respect to the line, that is equal to velocity of ship minus velocity of this line, right? Our relative velocity formula, just by using our relative velocity concepts we can write that expression there. So we can write this expression like this: VSL minus Vs minus velocity of ship minus velocity of the line. So which can be expressed as by using that right angle. That means you will get the vector notation if you are using, like you can write this as 4i cap plus minus 3j cap you can write here. The vector we can express like this: velocity of ship minus velocity of the line So velocity of the line is traveling along this direction here with a velocity of 3 meter per second. So that we can write this value as minus v velocity of the line we can write here. So that is the velocity of line, means that is our relative velocity concept here. By using this vector notation, you can solve this equation to get this vector, that means magnitude and direction of the resultant velocity there. So by using that vector notation, you can write those expressions there. So velocity of shape minus velocity of line you can write there, right? So that's relative velocity. So in general we use this relative velocity concepts to solve this problem here. You can easily solve these problems if you are using this vector method. I think you got an idea. And so now here let us come back to this problem here. With this problem now we will get in more clarity about this. So that means we need to apply this relative velocity of one object with respect to the other object, so that that object appears to be, that means it feels that it is at rest, and only the other object is moving here. So that means now here let us take an example here. Two ships are 10 kilometers apart on the line joining north to south to north. The ship A is farther north, is streaming to west at 20 kmph, and the ship B is streaming north at 20 kmph. What is their distance of closest approach and how long does they take to reach it? That means here two ships are there and they are not moving along the same line here. They are at 10 kilometers apart on the line joining the south to north. Ship A is farther north, is streaming towards west here. So that means now here you can solve this problem like this. So actually there the situation is so now let us take this. So this is the situation here. Here one ship is there here which is having this, and here another ship is there here, right? So this ship is having velocity along this direction here. This is suppose say VA, velocity of this ship, and this is traveling toward this north here. This is VB. And their initial separation is, this distance is given as 10 kilometers. This is a given distance here. Now they are asking this closest approach here. Both the magnitudes are same. VA and VB magnitudes are like 20 kmph only, right? And so now here the one method is we can use differentiation, and by using this differentiation we can solve here. The differentiation method means how to solve by using the differentiation method. The differentiation method is in the time t we consider here. In the time t, suppose it travels this distance here. It travels up to this distance, so which we can write this as VA into t. And here also it travels up to some distance here. So this distance you can write this as VB into t. Right? Now the distance between those two objects at that instant means this is the distance between them here. So got it? This is the distance between them. So I will draw this here. So this is the distance here. That means this is the instantaneous position of those objects. And so now this distance is nothing but VA into t. You can write here this distance, and this is VB into t. And so now this is the distance between them. And so now that x value I can write this as. So observe this. X value we can write this as, or x square is equal to what we can write is by using this right angle triangle here. So this side will be VA into t whole square. This I am saying by general method, differentiation method, without applying this relativity. Plus this side we need to write here. This side is nothing but you can write this as 10 minus VB into t we can write 10 kilometers. So this is of 10 minus VB into t whole square, right? So this is the distance between those two ships at any instant of time. And so now we differentiate this and equate to 0, because this x value will become x value is minimum, so x is minimum means its differentiation should be equal to 0. So by equating this differentiation to 0, you will get the t value. That means the time at which the ships will be at minimum separation, and by substituting this t value in this equation here, you will get this x minimum value. That is a general procedure to calculate this shortest distance between them. So then try by this method. Now let us come back to that our relative velocity method here, right? So is it clear? This is the at any instant of time we are taking this by using our general method. At any instant of time we are taking this ship is reaching to this position here, and so that this travels a distance of VA into t, and this ship B is reaching to this position here, so that it travels a distance of VB into t. And so now at the given instant, this will be the distance between those two ships, so which is x. So x square is equal to, we can write it as, by using this right angle triangle we are writing this. So this is a general expression for the distance between the two ships at any instant of time. Now if the distance is minimum, then its differentiation should be equal to 0. Then by equating that 0, you will get the t value, and by substituting t value in this equation, you will get the x minimum value. And now by using this relative velocity method, so this is now we are going to discuss about our second method here. So by using our relative velocity method, so what I can write is, suppose if I am writing this velocity of A with respect to B. So either here you can write velocity of A with respect to B, or you can write velocity of B with respect to A. There is no any problem in that. Any body you can consider as at rest. Now that means velocity of A with respect to B means, so that means now B is observing here. Similar to our example, now this is the line and this is the ship here. So now we are solving with respect to this line. That means with respect to B we are solving here. So that means we can write this as VA minus VB, right? And so now let us substitute these values here. Velocity of A with respect to B is nothing but VA value is minus 20 I cap. By taking our usual coordinate system here, this is x direction and this is y direction. Let us take here. So VA velocity is along this direction and VB velocity is along this direction. So minus 20 j cap. So then this is our velocity of A with respect to B here. That means as seen by B, the A appears to be traveling along this direction here. Got it? The A appears to be traveling along this direction. And so now this value, this equation we can represent like this. Let us observe this here. So now I will draw this diagram again here. Let us see this. So now as seen by the B, the A appears to be traveling along this direction here. So this is our B here. Now A, you can observe this, both the components are negative. Both the components are negative means then it is traveling along this direction here, right? So it is traveling along this direction here. So that means now this A appears to be traveling, a velocity of A with respect to B will be along this direction here. So this is the direction of this velocity of A with respect to B. Suppose this B is somewhere here, this is the B, and which is at rest. That means according to our, we are writing velocity of A with respect to B means this B is at rest. Now velocity of A with respect to B is along this direction. That means with respect to this B, the A appears to be traveling along this direction here. So with this velocity, right? And so by using as x and y magnitudes are same, you can say that this angle will be 45 degrees you will get. The angle here. And now the shortest distance, that means now it is at rest. Now the A is traveling only along this direction. That means the B feels that, this is the feeling of the B. The B feels that A is traveling only along, the B itself is at rest and A is traveling only along this direction here. So when it is A is traveling along this direction, you can find this shortest distance means that we need to draw a normal from here. So that means now this distance is nothing but our shortest distance here. Suppose this is say A and this is the point C here. So this is the normal we need to draw here. So this is a right angle triangle. So now this is nothing but our minimum distance here. This BC is nothing but our minimum distance. And so this way by using this triangle we can find this value here. Therefore, this now you can observe that in a single step we are coming to the conclusion here. No need of any differentiation here by using our relative velocity. In a single step you can come that conclusion here. Therefore, that BC value is nothing but minimum distance here. Therefore, that BC value we can write this as just you can apply this sine 45 here. So I can write this as 10 sine 45 by using this triangle. Directly I am writing here by using this triangle. This is opposite side we are writing here, or sine 45 if I write BC by AB you will get. So BC is equal to AB sine 45 you will get. So which is nothing but 10 by root 2 or which is 5 root 2 kilometers. So that is the shortest distance between them. And then the time after which this will happens means then we need to find this AC value. So then AC is also same. So this AC value is also we need to write this sine cos 45. This is cos 45. So which is 5 root 2. Now that means the time in which it happens means this minimum distance between the minimum means just we need to find time taken by this ship to travel from A to this point C here. So this time taken, this is nothing but now our minimum distance. So this x minimum is equal to minimum distance is nothing but 10 root 5. And now when this will happen means this value we can write this as AC by this, the boat has to reach, the ship has to reach this point here. And so then by this velocity of A with respect to B we need to write. Now it is traveling with respect to B, it is traveling with this velocity here. So then AC value is 5 root 2 by this value is nothing but you can write this as 20 root 2. The magnitude of this vector here. And so that it is nothing but 1 by 4 hour. Or which is nothing but 15 minutes. That means in 1/4 of this hour, the distance between the ships will be minimum, and that minimum distance is 5 root 2. So you can solve like this. The same thing you can solve by taking velocity of A with respect to B also. Sorry, velocity of B with respect to A also. Now this is the case when you are writing this velocity of B with respect to A. You can also solve the same problem by taking velocity of B with respect to A, you will get exactly the direction of this vector will be different here. Suppose if you are writing that equation here, so now let us see this velocity of B with respect to A, let us write here. This is velocity of B minus velocity of A, we can write. So velocity of B is nothing but 20 j cap. B is traveling along north direction, minus of minus 20 I cap. The A is traveling towards negative x direction, west. And so it is nothing but 20 I cap plus 20 j cap, you can write. And so with respect to this A, the B appears to be traveling along this direction here. Suppose if you are taking this diagram like this. So now the with respect to B, A is, that means now A feels that A is at rest and B is traveling along this direction here. Right? And so now again to find this perpendicular distance, we need to draw this normal here. So this is our A, and now the A feels that A is at rest. Now this B appears to be traveling here. So this is the direction of this velocity of B with respect to A. And again by using again this vector, you can observe this angle is 45 degrees here. This angle is 45 degrees. And so now again this AC value will be the shortest distance here. Now AC is the shortest distance there. So that AC is equal to, we can write this as x minimum, the minimum shortest distance between them. And which you can write this as 10 sine 45. So which is nothing but 5 root 2. Right? So time also you can calculate in a similar way. That means you may take any object as at rest. So from this what you should understand is any object you may consider at rest and other object will move here. Simply that relative velocity vector will be different here. In the previous case we are getting minus 20 I cap, minus 20 j cap. Now in this case we are getting like plus 20 I cap and plus 20 j cap. That means opposite vectors actually will get there. If you are finding B with respect to A or A with respect to B means. So that is a general procedure by using this relative velocity here, right? And so now let us see such another simple example based on this. Now see this example here. So now see this example here. Two ships are two roads are intersect at right angles. The core A is situated at P. This is the point P here. So it is situated at the point P, which is 500 meters from the intersection. So on the one of the road, the core B is situated at a Q 400 meters from the intersection on the other road. So this is a Q and this is at 400 meters from here. They start at the same time and travel towards the intersection at 20 meter per second and 15 meter per second respectively. What is the minimum distance between them and how long it will take to reach that? So right. So that means here also now we can solve like by taking this minimum distance, similar concepts there. So now let us see this. Just I am writing this velocity of P with respect to Q. So just velocity of P minus velocity of Q you can write. So velocity of P is, let us take, this is our usual coordinate system here. This is x and y axis we are taking. So then it is 20 I cap. Minus this velocity of Q is along the j cap direction. So which is minus 15 j cap. So now here this is the direction here. That means this is a vector here. Velocity of P with respect to Q means. And so now let us find both magnitude and direction of this vector. In the previous vector and the previous problem, we are able to identify that angle directly here. And so here let us find this magnitude and direction here. So mod of this PQ bar is equal to, this is 400 plus 225. So which is nothing but 25 meter per second you will get. And its direction is nothing but this tan alpha is equal to, suppose we are finding with respect to x here, then tan alpha is equal to, we can write this as y component by mod of this y component by x component. So that this value is nothing but 3 by 4 or alpha is equal to 37 degrees you will get, right? That means now the according to this what we are taking is velocity of P with respect to Q. That means Q feels that, or a passenger in the Q feels that he is at rest and only this A is traveling here, right? So only A is traveling towards this. And so now according to this our equation, what we are getting is the shortest distance we need to find here. And so that means now this appears to be traveling, this P appears to be traveling along this direction, which makes an angle of 37 degrees with this x-axis here. So that means now let us take it is traveling, appears to be traveling along this direction like this. So now let us see here, from this we are getting this alpha is 37 degrees. So then 37 degrees means then we can identify this direction along which this particle P core P will travel with respect to this Q is nothing but along this direction here. That means here I am drawing this line here, along this direction it will move. So along this direction it will move with respect to this core Q, right? And so now here again you may get doubt here whether it is this line is this side of this Q or it will come like this side of this Q. That just by identifying these angles you can get that clarity about that. So if you are directly joining the line points P and Q, then you will get more than this 37, and so that this 37 will lies before this core only. And so then we are getting this line like this. And so now this, if you are drawing this normal from this point, suppose I am assuming it is meeting at the point D, then this this QD is nothing but this is our point Q what we are taking here. This is our point Q what we are taking. So that QD is nothing but our shortest distance here. So to find this QD value, we need to find these sides here. So then by using here, I am applying this right angle triangle. So that is tan 37 is equal to, which is 3 by 4 is equal to, here I am taking some y. So y by this adjacent side 500 you can write. From this y is equal to 375 you will get. So this is 375 means the remaining distance CQ you can write it as 25 because this total distance is given as 400, right? And so now let us consider this now. So that means now I am taking this diagram will be like this. And so now here next what we need to calculate is to calculate this shortest distance. As we already calculated this QC value as 25. Now we can apply by using this right angle triangle. You can apply this cos 37 is cos 37 value QD by QC. And so now this QD is nothing but our x minimum. Therefore this x minimum is equal to 25 into this 4 by 5 cos 37 value, so which is 20 meters. So this shortest distance between those two cars will be 20 meters you will get. And next we need to find the time taken, time after which this will happen. So then further we need to calculate this total distance PD here, the distance between P and D. So for this first we are calculating this distance here, PC distance we are calculating. So for that let us calculate this CD value, that means PC and CD values we need to calculate here. So CD value we can calculate by applying this in the same triangle QCD sin 37. If I apply, then 3 by 5 is equal to CD by QC you can write, and from the CD is equal to 15. So the CD distance will be 15 meters you will get. And now again apply this Pythagoras theorem by using this triangle here. By using this triangle, if you apply the Pythagoras theorem, you can calculate this PC value. So that PC value is under root of 500 square plus 375 square, which is 625 meters you will get. So that this PD value is nothing but the 625 plus 15, 640 you will get. And therefore time taken we can write it as PD distance by that modulus of this PQ, the velocity of P with respect to Q, which is 25. We already calculated this value here. This is 25 meter per second. So if we substitute those values, then you will get 25.6 seconds here. So it is a distance of this closest distance is 20, and this will happen at a time of 25.6 meters here. So that is the procedure to solve such a relative velocity, that means the shortest distance problems with the help of this relative velocity here. So let us take another example here. The figure shows two projectiles are fired simultaneously. Find the minimum distance between them and during their time during their flight. That means now we are coming back to the projectiles here. Now these are the two projectiles here. So that means now with the help of this relative velocity concept in any either projectile problems or whether they are traveling along straight lines, you can calculate their shortest distance between them by using our relative velocity concepts here. So that means now here I am taking this, these are the projectiles here. One is projected at 20√3 meter per second at an angle 60 degrees. And this is the particle B is projected at 20 meter per second at an angle 30 degrees as shown here. And the distance between them is given as 20 meters, right? And so now we need to write this velocities of A with respect to B or velocity of B with respect to A here. So here we are writing this velocity of A with respect to B. So velocity of A with respect to B, if I write, so let us express first these velocities in components form here. So 20 root 3 cos I cap plus sin j cap, and here this its x component will be negative here. So then it is minus 20, and they are taking here, it is expressed like this angle they are taking here 150 degrees, or you can take, if you are taking this angle directly, then you can take this as minus cos 30 degrees you can consider here. Instead of this, you can also write this value as minus cos 30 I cap and a plus sin 30 j cap. Sin 30 j cap you can write, right? So you can also express like this. And so now by after simplifying this, we are getting this relative velocity of this A with respect to B is at rest. That means A with respect to B means we are assuming that B is at rest. Now A is traveling with this velocity here. And let us find, after getting this velocity, relative velocity vector, what we need to do is we need to find this angle, that means direction in which this particle is moving. This relative velocity is there. And after that we can find the magnitude of this vector here. And so now we are finding this direction, the tan theta is equal to y component by x component, then you will, tan theta means we are taking with respect to x here, then which is 1 by root 3, or which is theta is equal to 30 degrees we are getting here. Now you can observe this diagram like this. Now we are taking this relative velocity concept here, velocity of A with respect to B. That means now with respect to this B, the particle is velocity of A with respect to B is along this direction here. So that means now this is our case here. So that means like previous cases, if you draw this diagram here, I will draw this diagram, say this velocity of A with respect to B. B is at rest, now A is traveling with this velocity here at 30 degrees, actually it is traveling here. So we need to draw this diagram like this. So that means now this is a diagram here 30 degrees. Now the shortest distance between them is nothing but from here you need to draw this shortest distance perpendicular like this. They are drawing it in reverse way here. So then don't consider this triangle, you may get confusion regarding this. So then this is the diagram what I am taking here, right? So then in this diagram now we can consider that suppose this is ABC, if I consider, then BC is our shortest distance here. And so then this angle is 30 degrees. And now this distance is 20 is given here. So simply you can apply this sin theta here. Therefore the sin 30 is equal to our D minimum by AB, and therefore this D minimum is equal to AB by 2, we can write sin 30 value is 1 by 2, so that this value is 10 meters. So like that simply you can calculate this relative shortest distance between those two particles there, right? So like that we can find the shortest distance between the two particles, even in case of this projectiles also, right? Even in case of projectiles also you can write the shortest distance between those two particles by using our relative velocity concepts like this. And now note this problem and solve this. So here the particles are, that means write down the data here, two particles, let us name them as A and B. Two particles A and B are traveling towards horizon along x and y axis, with the speeds v1 and v2, as shown in figure, with the speeds v1 and v2 as shown in figure. At the given instant, the distance of particle A from the origin is L1 and distance of B from the origin is L2. Find shortest distance between these two particles. And also find when this will happen. So this problem, actually why I am giving this problem means, if you are solving by using our relative velocity concept, it will be again difficult for this. because here in terms of values are not given here. If values are given, then you can find the exact direction. This means this alpha direction here. See this, that after getting this relative velocity, we need this direction here, so that to identify the direction along this particle is moving here. So this is the direction of velocity of A with respect to B. To conclude the direction, if your numericals are there, then you can identify the directions easily here. So but in this problem, such a numericals are not given here. So when the numericals are not there, then it will be somewhat difficult to identify the direction. Suppose velocity of A with respect to B, if you are taking, whether you are getting along this direction or along this direction, you may get some confusions. And that theta calculations are also difficult here, because here we need that sine theta or cos theta calculations here after getting these directions. So that also becomes lengthy in terms of this V1 and V2. Then what is a better way here is you can calculate our calculus method here. Calculus method is nothing but by writing the separation between those two particles at any instant of time, and then we differentiate that. That means we differentiate that shortest distance, and we differentiate the distance between those two particles, so that you will get this time at which that separation will be minimum, the distance will be minimum, and after that you can calculate that the shortest distance here by substituting that. That means in the first problem I explained one method. In time t travels a distance of, you can consider it as v1 into t, and it travels, the particle B travels a distance of vt into t. And suppose those particles are reaching these points here. Suppose one particle is here and other particle is here, for example. Then you need to take these distances here, and from that you need to write this value here. So this distance will be L1 minus V1 into T, and this distance will be L2 minus V2 into T. And so then by using this we can find this distance here. Suppose this is B dash and A dash. So B dash and A dash is the distance, that means that xy is the distance between those two particles at any instant of time here. So then write an expression for this x, and dx by dt value should be equal to 0. Then differentiate that and equate to 0, then you will get the time expression, and by using the time expression you can find this shortest distance between them. Calculation will be some lengthy only, because the values are not given here. This is important problem only. So then values are not given, so complete that problem. So differentiate that and equate to 0, and then find the separation between those two particles. That means minimum separation between those two particles, right? So it is a way of finding the shortest distance between two particles there. So next year in projectile motion, relative velocity will be there, and I will explain those concepts in our next class. So try to complete this, understand these problems here, and how to solve by differentiation method and how to solve by this integration method. That means by relative velocity concepts here. So that means if you are solving by relative velocity concepts, then it will be easy for the numerical problems, right? So try to follow that procedure for this. And for this problem, as I said, the problem is in terms of this unknowns here, that means V1 and V2. So then variables here, so that it is better to follow this differentiation method, right? So then the remaining concepts are there based on the projectile motion, that I will explain in our next class, right? Thank you.